In technology, this is a very exciting time. It is unusual to have so many different technology revolutions at the same time. So I will talk about which ones impact medicine and healthcare. There are new types of sensors, so we can now detect many things we could never detect before. New types of understanding what goes on inside the body, in part because of the sensors, in part because of, in general, increased knowledge, in part because in the study of molecular things such as DNA and other important medical components, we are beginning to realize everybody is different. And so we can now start to do individualized diagnosis and individualized treatment. Today, we simply label a simple disease or ailment, but we never get into the differences that many different people have, even with the same diagnosis. And we give the same treatment to everybody, even though everybody's body is different, and most especially the gut, the intestines and stomach, and where that's the second most powerful nervous system component, and the chemical situation there is very complex and makes everybody unique. So we are starting to understand that, which makes a big difference in medicine. Second, we have much more powerful computers than we ever had before, dramatically more powerful. By that I mean 1,000 times or even 1,000,000 times more powerful than the kinds of systems that we still find in hospitals and medical care today. And of course, there is the role of artificial intelligence, which is important for many things. For example, it is very good at making transcripts so that physicians don't have to spend all of their time making notes, and very good at translation. And today, the large language models are complex. And so on the one hand, they cannot be trusted. On the other hand, they're very powerful and useful. And I tell people you should think of them as you just hired a new assistant who works very hard and tries to be helpful, but does not have enough knowledge. And so when you ask them to do a job, they do it. But it's not quite what you wanted, so you have to explain again. And second, you can't trust it. You have to go and look carefully. But even so, it can give you many new insights. And in medical treatment, well, the amount of knowledge we have in the world is so huge, no physician can know it all. But the system knows it all, because the system has read all of the medical literature. And so it is really excellent about answering questions and finding things, because you cannot know enough to do it, but it knows enough to look for everything. So this will change science, it will change law, it will change medicine, it will change many things. It also, part of the revolution is the combination of robotics and the new large language models and the new AI. Because the robots have been a bit clumsy, and to program a robot to do your work is very difficult. And today we don't have to do that anymore. The new robots learn by watching you and by then experimenting themselves, and they can learn to do many, many things that we never thought were possible. Most of this work is still in the research laboratories, but it will soon be in practice. Now let me mention what Apple has developed. if you read the newspaper reports about it, they all say it's no good. And they say it's very expensive and not very good. But ignore that. Because these are writers who don't understand. They are talking about the home. Would you buy it for your home? Oh, it's so expensive, and a big helmet. So, but I went to a hospital. It's Sharp, S-H-A-R-P, Sharp Hospital System. It's the largest hospital system in San Diego, California. They bought, I think, 12 units. They're $5,000 a piece. They bought 12 of them to experiment. And they liked it so much, they bought 1,000. Yes, 1,000 of them. Because a medical instrument for $5,000, that's not expensive in the hospital. And 1,000 of them, that's $5 million. That's still cheaper than many medical devices. And so they had a 2-day conference. And they brought in, there were people from all over the world who are interested in using these devices in medicine. It has several capabilities. First, you can just have a normal computer window to work on, but you can have as many as you want. I have one there, and I have one there, and there, and there, and there, and there, and there. So I can see that's the anesthesiologist, and that's the blood pressure, and this is this, and this is this, and this is my notes about this patient, and this is my drawings, and if I'm doing surgery, I planned how I would do the cutting and what I would do, and so here are my notes there. So I can see them all at once. I can move them around. And when I look at the patient, I can see the patient, and if a screen is in the way, I can move it. But I can also make my notes, the path, the surgical path, I can put that right on top of the patient at the exact spot. Because this is called augmented reality, where you augment, but most of those have great difficulty in synchronizing the material with the thing you're seeing. But because Apple, you don't see the real world, you see it through a camera. But it's so good, I thought I was seeing the real world. I didn't realize that I wasn't looking through the helmet, because that's one reason it's so expensive. It's such high quality. And but that means it's easy to superimpose the surgical information right where you are working. So the surgeon is still doing normal surgery, but you can have all the information you need. If you actually watch a hospital, in most operating rooms, they have big monitors. So to show you the state of the anesthesiologist you may ask and they'll tell you. But so you're doing the surgery, you have to look up and look there. Now you don't have to, because you can just move the information you need right over the patient where you need it. And so the people who are using it for surgery are very excited about this. And now the residents and the people learning, they can have the same system. They're looking, and they see the same image you do. And so they can learn a lot from watching you, because they can see better now than they could see. If you simply watch, you can't see everything. It's too small, it's hidden. Now they can see it. It made it so easy to understand. And now they're using this in medical education. The book publisher, Elsevier, they do a lot of the medical books with all sorts of wonderful detailed drawings and so on. So they have taken all their information and they put it into 3 dimensions. And so a lot of the things I was seeing comes directly from the Elsevier work. So a very senior publisher from Elsevier was at this conference. And it was clear that all the people at the conference, maybe 200 people, again, from many, many different places, thought this was the future of medicine. Well, I'll tell you another story. A friend of mine, a very senior professor and really great technologist at the University of California, San Diego, he suffers from, so he has been measuring himself every day for 5 or 6 years. And so he points out that normal medicine, they take some measurements of you, every couple of months, one measurement? He measures, so he does it, it's all the time. So it's the first time anybody ever saw how the measurements change each day, in fact, each hour. And so first of all, he was able to present, he runs an institution in the university. So he had a wall bigger than this wall with very high definition displays. And he could put all his data there, and so you could look at all of it and see things people didn't realize how much change there was, even from moment to moment. They would look at the change today, and 6 months ago, it's different. Well, you can see here's the change, here it is, and here's 6 minutes ago. And it was a bigger difference than 6 months. And so first of all, he had all sorts of data. Second of all, he clearly knew he needed an operation. So he had MRIs, and he transformed the MRI, sent it to a 3D printer, and so he printed out a picture of his colon. Okay. And then he decided which surgeon he wanted to work on him, and he went to the surgeon, and I went to the grand round with a surgeon who gave a talk after the operation, and she said she's never had a patient like this. Usually she has to explain in great detail what she's going to do. But this patient came in and said, here's what you will do. And the patient showed her the MRIs and took out of his pocket a model of his colon and said, I want you to cut here and then cut here and combine them. And that you also have to, because of you cannot enter the body in the normal way. You'll have to enter it from here. And so it was all there. Everything was planned with great diagrams and photographs and computer-generated images. But that's kind of the future. So the other thing that people are using the Apple spatial computing for is planning the surgery beforehand. Because you can have a model of not a model from Elsevier, because Elsevier's model is who knows who it is. And inside the body, it's all different. And so you have, because of MRIs and X-rays, you have a model of the person. So they can plan the surgery exactly around you. And that means when they do the operation, they can put the plan right on top of what they're doing. And because of these illustrations, if you had a normal family, it makes it possible to explain to the family exactly what you were doing. So actually, let me change the subject slightly. Maybe 2 years ago, I visited Philips, the company, Philips, in Eindhoven, the Netherlands. And they were experimenting with a prenatal care. Okay. So when you have a premature birth, you put them in an incubator. But the incubators usually are covered in plastic, and you can see the baby and so on. And it's very bad for the baby. So it used to be that most premature babies died, but today they live, but they often suffer from ailments afterwards. And they said, look, first of all, through the plastic, you don't get the normal light and dark cycles. Second, the nurses come in at all hours of the day and night and have to wake up the baby. And also, all the noises around go into the baby. So then So what they did is they devised an incubator that you could not see through, and had soundproof material over it, and so, but with an infrared camera that was always watching the baby, so you could always tell what the baby was doing, but you didn't have to disturb the baby. But also what they did is they developed the notion of, here's the incubator, and there is a small bedroom for the parents, so they could stay there and be closer to the baby. And then they had a big television screen with all of the information, and they did very cleverly, they had 3 different kinds of screens, and you could just push a button and see which one. So one for the physician, which would tell you all the medical information in the medical language. A second for the nurses and technicians, so that they would know the scheduling of medication and of their tests, and where they could enter their information as well. And third was for the family. So it was this. So the information was now presented in a more understandable language with some nice pictures and so on. Yeah. And what I thought was nice was, if the family only got to see the family one, they might think that you were hiding information, and so they made it so the family could choose to see any of them. Yeah. And so they could choose the physicians and discover they couldn't understand it.
Yeah, it was better.
But it was good that it wasn't secret. Here it is. And you can read a little bit, but this one is easier for you to understand.
Okay.
There are a horrible problem in the operating room.
Okay.
And so you can't think anymore. And if you watch what they do, is the first thing they do is go turn off all the alarms.
Okay.
Wasting time.
Yeah.
But you can't think.
Not intelligent.
This is true in big factories as well, and power stations. I've seen the same thing. The alarms are so bad, and that you don't even know what they mean, and you can't even, they all sound the same. And in the home, we have things that ring too, and they use the cheapest, so it goes beep, at a very high frequency, because that's the cheapest type of sound.
Okay.
And so people our age, we can't hear them, because with age, you lose the ability to hear high frequencies.
Okay.
So we can't even hear them. And then even when we do hear them, we don't know which device is beeping. So all of this is a great opportunity. It's a communication problem, and it's a human-centered design problem. And the other problem, though, is that every company does things differently. And so infusion, if you're in a medical situation where you have an infusion and there's an infusion control, every brand is different.
Yeah.
And I've had to explain to nurses how to work this one, because I knew that one and she only knew these other 2. And there have been a lot of medical errors, major errors. If you put the numbers in wrong, even if you know you put them in wrong, it wasn't designed to make it easy to detect and easy to change. So you know when you made an error, but now what do I do? How do I correct it? And so some people would unplug the equipment and plug it in again, hoping that would reset it.
Yeah.
But some of the equipment is so smart, it remembers the values, so it remembers these wrong values. Yeah, but it's not smart enough to say, oh, that's a dangerous value, are you sure you meant it? Well, we're going to have to add that kind of smarts in, but then it interrupts you. Every time you try to do something, it will say, are you sure that's the right number? And sometimes it's a good question, and other times it gets in the way. And I can keep going about I've toured hospitals in the United States for part of the National Academy of Science Studies, and we never saw one that didn't have many problems. Yeah. And I said, I'm not going to write about social science and design, because I think that's the symptom, that's not the problem. The problem is the education system in the world. And it comes from, blame the Greeks and the Romans in the old days, where there was a teacher, and everybody listened to the teacher give lectures, and you memorized the lectures, and that's problem one. Lecturing is the worst way to learn.
Okay.
It's the easiest to teach. And so I tell my students, we will not talk about teaching. We only should talk about learning.
Mm-hmm.
And they are very different. Second, in those early days, well, Da Vinci, a good example, could be the world's leaders in how many different fields? Just an amazing number of fields. He would make wonderful, inspirational and creative inventions and so on. Not just art, but also inventions of physical devices, a helicopter, war machines, and all sorts of things. You can't do that anymore. The amount of knowledge is so large. And worse is it becomes, when you say we have to bring in the social sciences, I say, well, wait a minute, there are how many different social sciences?
Yeah.
And they're all different. But even in any social science, I don't know, take psychology, which is sometimes called a social science, sometimes a behavioral science. So how many different kinds of psychologists are there? Or take computer science, or people talk about STEM education. I'm opposed to STEM education.
Okay.
And I say, you probably talk about it here in Italy as well.
Yeah, of course.
I say, I'm an expert. I've had a lot of education in science and in technology and in engineering and in mathematics.
Yeah.
I have 2 degrees in electrical engineering and so on. And why am I against it? Well, don't we do things for people? How come there's nothing about people in STEM?
Mm-hmm.
And all the people who want to include STEM, they want to get rid of the humanities. What good are they?
Yeah.
That's what they say. What good are they? What good is history? What good is philosophy, etc.? And some people say, oh, we should add art to STEM and make it STEAM. And some people say we should add humanities and make it STEAM. But I say no. Because they still, when you say you should be trained in STEM, they mean you should take a lot of science courses and a lot of technology courses and a lot of engineering, a lot of mathematics, but they're separate.
Yeah. Mm-hmm.
And you never know why you're learning this stuff. And I say we should stop teaching subjects. We should start teaching projects and problems.
Mm-hmm.
Because once you start working on a real problem, you cannot just learn your own discipline because it requires all the disciplines together.
Yeah.
And that's, by teaching this, you begin to understand why you need to know the other areas.
Mm-hmm.
And it's also why you need to know the history of the issues and the history of people. And because cultures are different and cultures result from their history. And you have to know about philosophy, yes, because why are we doing this? And also ethics. We don't normally teach ethics in many fields. Now, in medicine, they spend a lot of time about ethics, but not in all of the engineering fields, and not in design at all.
Mm-hmm.
And but ethics is so important. I say it should not be taught in the course. Because if you teach something in a course, it should be taught in it should just be automatically part of everything.
Yeah.
And so I want to change all of education.
Mm-hmm.
I also want to. I also say we should train our students to cheat.
Yeah.
And here's why. So, what I'm trying to, I think, I didn't know what question you were going to ask me about, but I wanted to make sure that we realize that I didn't want a question about the use of AI in medicine, say, because it's part of a more complex system about how technology gets used in the world. And also, you were going to ask me about education, but I pointed out, I think most people you ask will explain how AI should be used in education. And and my answer is, we have to change all of education, how it's done. And the notion that you listen to the professor just so you can remember so that when you get an examination, you can repeat back what you heard. Well, I don't want people to repeat back what I say. I want people to disagree with what I say.
Yeah.
I want to have it, because when they disagree and we discuss it, they can't disagree and discuss it unless they thought about it.
Yeah.
Because I don't want them to say I'm wrong. I want them to say why.
Mm-hmm.
And as I point out, because if I really am wrong, I want to know.
Yes.
So thank you if you really thought about it and realized I was wrong. Good.
Mm-hmm.
I won't say that anymore. I'll change. Mm-hmm. But and if I decide I'm still right, well, first of all, I often say, okay, that means I have not been explaining it well. And but even if, but it really helps because that's, you don't learn from hearing a lecture. What a lecture is good at is motivating people, explaining why this is important, or showing how things come together, or maybe summarizing at the end of the class. But to learn, you have to really struggle. Mm-hmm. And that's where assignments are so important. But a homework assignment, I hate it. But if I'm working on a project together with other people, and it's been an interesting project, but then I learn a lot. Mm-hmm. And I may even learn things that the professor never thought about. Because in order to work on the problem, I have to bring in this and learn about that. So it's real. What I like is that the professor will be learning also.
Yeah.
It's a completely different. Actually, it's like the old apprenticeship learning. In some sense, that's what medical education is: lots of lectures and lots of memorization and exams. But then afterwards, you're still not ready to be a doctor.
Yeah, you need to practice.
Now you're an apprentice.
Yeah.
They call it an internship, and then they call it a residency. Since so many of my medical friends keep complaining to me about that medicine is having so many specialists today and you need the specialties. You do need them. But you need the generalist who knows how to put it all together. And we no longer have so many generalists in medicine. And what happens is every specialist sees their specialty and treats it. But they don't realize that the patient, almost nobody suffers from one special thing. You have multiple things happening. So most doctors do not see you as a person. Mm-hmm. They see you as their specialty. And what we have to do back in medicine, we have to go back to seeing you as a person.
Yeah.